whole world, right? The whole world will run house, factories, companies, all those things. Without electricity they can't survive, right? Everyone are surviving through electricity. Very essential. It is important for everyone in your life, that is electricity. So today we are going to explain. So in these chapters we will study this topic up to here. I will explain, and remaining in the second part I will try to explain in the another part. So today what we will study? Today's introduction, that is for electric charges and electric current. Right? Today we will study this. Charges means what? Charges means the charges, that is for electric current we will get the electric current, that is for positive and negative charges. Right? Positive and negative charges in the electrons. So, and the current will flow into the one direction to another direction. The current will prepare the both charges will add together. Then the current will make. So next topic, that is for electric potential and potential difference. What is a potential difference means? So let us study in the detail in that part. And electric circuit. Since electric circuit and Ohm's law, that is what we will study in the VI graph. That is for VI graph, that is volt into current, that is for graph. And resistance we will study in this topic. Let us start the first, that is for we will study, that is for electric charge and current. Now the first I told electric charge. What do you mean by electric charge? A charge is a fundamental. Fundamental means basic property like mass of matter. Mass of matter. For example, I have one ball, rubber ball. In that rubber ball, mass of quantity the rubber will be there inside. Mass of quantity will be there in the rubber ball. So rubber ball. So in that rubber ball, mass of quantity is there. Then we call it as mass of atom will be there. That is mass of atom. That is what charge will be there. Then the ball will move. If there is no mass inside, the ball will down. There is no mass. Then there is no charges will be there in that ball. Right? A charge is a fundamental. Fundamental is basic, like mass of matter. Right? So there are two types of charges. One is positive charge and another one is negative charges. Right? And the charge symbol is considered as a small q. That is q. Charge is q. Positive charge q. That is for positive charge and negative charge. We can keep like that. And like charges and unlike charges attract. Like charges repulse. Repulse means it will go in the opposite direction. So we are taken the two bar magnets from here. One is north pole and one is another one is south pole. Similarly, we are taken the magnet, one more bar magnet. These are the two bar magnets. That is first one is south pole and this is one north pole. If you take on south pole to south pole near to that, it will not attract. It will repulse. It will go in it will not attract. That is for like charges. And unlike charges, like means they both are same. And we are taken another two bar magnets. Here also you can see. That is north pole and south pole. This is north pole and south pole. South pole and north pole we are taken together. Here it will attract. Then we call it as, that is for attraction. That is for unlike charges attraction. Attract with that. And one more point will be there. By a SI unit of a charge is coulomb. The SI unit of charge is coulomb. That symbol is C. That is for C. Did you got understood? So these points are there. There are two types of charges. One is positive charge and another one is negative charge. And the charge symbol is Q. That is for Q plus charge and Q negative charge. Unlike like charges, it will repulse, and the unlike charges will become, that is for attraction. The SI unit of charge is coulomb. Understood? Now, the second point I am going to explain, atoms are made by the properties. Atoms, you know the atoms, just as if you take a rubber ball. So it was present. So first one is electrons present in that is for negative charge. And protons. Protons are positive charge. Electrons are negative charge, protons are positive charge, and neutrons, there is nothing. Neutrons means it has a neutral point. There is no electrons, no positive and negative, no positive and no negative will be there in the neutrons. Charge of one electron is equal to electron E. That is 1 electron is equal to 1 point. The value of the 1 electron is equal to 1.6 into 10 to the power minus 19 coulomb. Understood? So second, number of electrons in 1 coulomb. Number of electrons is equal to, electrons means we know that 1.6 into 10 to the power 1. And 1 coulomb of charge, that is n is equal to 6.252, that we will get the answer. Exactly we will get. How? Means, listen, Q is equal to n into J. Charge is equal to number of electrons, and number is equal to number of electrons is equal to number of n is equal to q by charge divided by electrons. N is equal to q by a. N is equal to q by a. I will write it properly. N is equal to q by a. Q is charge 1. Charge of electrons. Charge 1 divided by electrons value is there. Electrons value will be there. That is for 1.01 divided by there. Minus 1.6 into 10 to the power minus 19. If you divide these both values, you will get exactly the 6.25 into 10 to the power of minus 19. We got here number of charges. Here will be the one charge of 1 coulomb charges. That is 1 electron in 1 coulomb. That of charges n is equal to 6.25 into 10 to the power of minus 19. If you have taken that value in the reciprocal, the value will become decreased. That is in 1.6 into 10 to the power of 18. What understood? Now, I am going to explain that is for current. Current, it is a flow of charges per unit time. It is a flow of charges per unit time. So, we have to find it mathematically. If we solve mathematically, current is I. The symbol current is I. I is equal to charge divided by time. Charge divided by charge per unit time. That is for charge divided by time. Charge is Q and time is T. That generally directly we will write in mathematically I is equal to Q by T. That is for, and the SI unit of current is ampere. The SI unit of current is ampere. That symbol is A. And current is measured by ammeter. Current is measured by ammeter. What is ammeter? Ammeter, it is a device to measure the current. It is to measure the current. It is a device. It is a small device like that. This is like positive terminal and negative terminal. This is box. That is ammeter. The reading will be such here. Like that it will come 1, 2, 3, 0, 0.1, 0.2, like that it will come in a diagram. The needle will deflect from here to here. The two electrical cables will be there. The wire should be connected to that. It will be a battery. This is for negative terminal. This is positive terminal. Like that we will connect and the current will deflect. Then it will measure the current of flowing of current. The flowing of current will show that is ammeter. That is ammeter is a device, right? So what do you mean by ammeter? I already taught. So that is a device, right? Ammeter the symbol is A. It has low resistance. It has low resistance. The flow of current is, it will take the exactly measure to be a device of the current, and it always connected in series. Series means you know that. So series means one, another one. That is in series, like that we are taking. For example, in one row it will take, in one row 3 to 4 of them is standing. That is we call it as that is in series, right? If parallel also is there, parallel means front one, upper one, down one, another down. So like that it will take in a, that is for parallel. So only it is given in a the diameter is connected in always in series. The electrons are moving just as this is a metallic conductor or metallic wire. You know the cable, thick core of the metallic wire or conductor. Conductor means what? The current carrying conductor is what? It is a device, it is one of the object, it carrying the current. For example, we have to take an iron rod, it carries current. Then we call it as it's a current carrying conductor, just as a metal rod. Iron rod we have to take, copper wire we can take, aluminum wire also we can take, and that conductors carrying current. That rod is conducting current, carrying current. It carries the current. That is nothing but that is for conductor. Understood? So it was connected in one direction. That is in a negative electrons. Understood? So here current, the electrons move freely randomly. When the current will flow in the current electrons are there, it will move here and there. Right? Already know that. We want to take the electrons in one direction. They are moving randomly here and there, just as a what we will take in a scattering of light. You know that colloidal particles, that is more particles are moving in a here and there. The dust particles are moving like that. The electrons also moving here and there in that atoms. So if you connected that atoms, or this is a conductor, if you connect it to a battery, that is for battery, don't get confusion. I have here connected a battery. Battery, there is a positive terminal and negative terminal here. These are the two terminals. The cable wires are there connected to the conductor. Then the electrons will move in one direction, either this side or only it will come to the positive direction. Only it will move in a what is a positive direction. Electrons will move in a positive directions. Understood? Now, what more thing I am going to explain? This is, so if you connect it to the battery, the electrons will move in only in one direction. This is in positive direction. That is in positive direction. If you connect it to the battery, then the electrons will move in one direction. Now, potential difference. So here, one, this is containing water, so less, this is full. So here, you see here, this is containing water, trough containing, this is 2B. So first of all, I will explain the definition of that potential difference. Work done to move in a unit charge from one point to another point. So work done is going. You see here also, the electrons are connected to the battery. Then the electrons are moving in one direction. That is also work done is going on. What work is there? Work done is going on. Battery is connected. Similarly, the work done is to move and unit charge. The electrons are moving from one point to another point, one point to another point, one point to another point. The mathematically of the potential difference, that is PD, that is volt. Mathematically we are solving here. Work by charge. Work by charge. Work is W and Q is charge. V is equal to, that is potential difference is V. That is Q W by Q. That is we can, the unit also we can write V is equal to joule by coulomb. Work done is, that is joule, and charge is, that is for coulomb, that is positive and negative, that is for charge, that is for coulomb. The SI unit of potential difference is volt. The SI unit of potential difference is volt. When 1 volt, when 1 joule of work done, when 1 joule of work done is carrying 1 coulomb, charge, then the potential difference is 1 volt. What we will get? That is 1 volt. Understood? So, I don't know what you people are understood or no, that is potential difference means. See, I will take one example. This is a tub containing water, one is glass beaker containing water will be there full up to here, and another one tea container, that is for a tub containing, that is for a glass, that is for another one beaker I have taken, that is water is less here. If you connected one a tube that is open, that if you open that both side, the flow of current will go from here A to P and it will increase the water level. to up to the level. Right? If it will decrease, if it will decrease up to here, now this is also will decrease and it will increase up to the level of that. That is nothing but 1 molar from here to here. 1 joule of flow of water in another point. From one point to another point of 1 coulomb of charge will go, and it is equal to, if you divide that is volt is 1 volt. So equal to that 1 divided by 1, if you do it, then it will become 1 volt. Did you got understood? Similarly, the both it will come from one direction to another direction, one place to another place. The water level will move from here to top to bottom, it will decrease, and here will in the B will increase. The both will work equally. Understood? Now listen. In the potential difference, 2 points I have told. That is, it is the potential difference is connected or cell or battery are the device to maintain volt. Right? That is volt. That is V, that is for potential difference. Cell or battery are the device we have to maintain the flow of current. The device to maintain. Right? Potential difference is measured by voltmeter. Potential difference is measured by voltmeter. So here, what do you mean by voltmeter? Voltmeter is also, it is one of the device. Just as a device, just I will tell. This is this is also needle. The number LED will be there. This is connected to the 2 terminals of the wires. One is positive, one is negative terminal. The both terminals are connected to the battery. Right? So a voltmeter, the symbol is, that is V. The voltmeter is V. That is, I have done a circuit diagram. It is in. So here, first point, it has high resistance. Ammeter has low resistance. Then voltmeter has high resistance. It always connected in parallel. Ammeter is connected in series. That voltmeter is connected in parallelly. Understood? Parallel means one here, like that it will connect. Understood? That is in parallel. Series means here one, here one, here one, here one. This is in series. This is in parallel. This is in series. This is in parallel. We know that the parallel lines. Parallel. So it always connected in parallel, but ammeter is connected in series only, and the voltmeter is connected in parallel. Current flows through from higher potential to lower potential. So the current will flow from higher potential to lower potential. From here, start from here, that is for higher, that is positive to negative terminal. It will flow from higher to negative. Okay, so this is the connection of the circuit will be there. This is the bulb, and this is connection to the battery. That is plug key. We have to switch it and switch out. Okay, battery. This is plug key. The pin will connect inside the hole. It is connected means the flow of current will start. Right? If we remove, the flow of current will not flow. That is for battery. That is for bulb. And this is the voltmeter we are taken in the device, that is in parallel. That is in parallel to the bulb. Either we can take up also, no problem. Okay, we can arrange in a up also. So the voltmeter positive, from that direction, the flow of current will move from positive to negative direction. That is the given. That is, so it was connected in parallel. Remember the points. It has high resistance, and it has connected in parallel. It is connected in parallel. Current always flow from higher potential. This is higher potential to that is lower potential. Got understood? Understood? Okay. Now I am going to explain, that is for Ohm's law. What Ohm's law will explain? What has given Ohm's law? Potential difference across. Already you know the potential difference. I told the 2 beaker containing water we have taken, the flow of water is moving from one place to another, one beaker to another beaker, that equally they will make, that we will get the answer is also both equal. Right? So the Ohm's law potential difference across the 2 points of a metallic conductor, we know that metallic conductor is directly proportional to that, to the current passing through the circuit, provided its temperature remains constant. The temperature should be remains constant. Just assume as a wire, the bolt ends, they are connected in positive to negative. The bolt is connected to the battery, right? Battery. So here that is connected to the battery. Then the flow of current will also it is connected to the battery and it is connected to the voltmeter. Then the temperature of the conductor is remains constant. That is constant is V is proportional to I, and V is equal to I into R general form. That is for R is nothing but resistance. R is nothing but resistance. So the flow of current in straight direction. This is I x-axis. I have taken current, and that is for volt. That is a voltmeter we have taken, and the current, the flow of is going in either in this direction straight, or maybe in this direction, or in this direction. Then it will flow from one place to another. So that is nothing but V is equal to I into R. Current into resistance. That is resistance. What do you mean by resistance? Resistance. It is a property of conductor to resist. Resist means maintain. To resist the flow of charges. The flow of charges will move from higher or lesser, like that it will go. It controls to maintain. It controls to maintain exactly. It not should pass the flow of current is high and or maybe it in low, but it is the property that conductor to resist. Resist means it have to balance the flow of charges. It balances a flow of charge. Okay, and the SI unit of ohm is symbol, that is ohm. Ohm is equal to V by R. V is equal to I into R means R is equal to V by R. Resistance is ohm. That symbol is ohm. That V by I, volt divided by, and that is for current. Understood? Potential difference V divided by, potential difference V divided by I. Understood? So next, and that I am going to explain the rheostat. What do you mean by rheostat? It is an electronic device. It is an electronic device used to control the current by varying the resistance. What it may be, the flow of current will be there in the resistance. It controls the rheostat. It balance the flow of current exactly how much required the current should be need. That either it will flow exactly the which medium it flow the, it is in medium only it will flow the current of that device we have to apply. That is for rheostat. Understood? Now here, now I am going to explain resistance of a conductor depends on the factor. What are the things will be there? Resistance of a conductor depends. So first, directly proportional to the length of conductor. Length of conductor. This is length of wire or length of conductor. Just as a iron rod or metal, copper wire or maybe aluminum wire. Right? So first, directly proportional to the length of conductor. So if current is increased and resistance also increase, R is proportional to I, R is proportional to I, directly proportional to the length. This is length, so R is proportional to the length, that is directly proportional to the length. If length is increased, then resistance also increase. Resistance also increase. Or if length will decrease and resistance also decrease. In that first, if it is directly proportional to the length, right? Length of a conductor. Second one, inversely proportional to the area of cross section. This is the conductor. This is the cross section area. So here, if the cross section area, if inversely means we have to take 1 by A. That is for area. That is R is resistance. 1 upon A. It is in inversely. Inversely means we have to keep into that inversely proportional. 1 by A. If area is increased, then the resistance will be decreased. If area will be decreased, then the resistance also increase. That is given inversely proportional. R is proportional to 1 by A and R is proportional to 1 by by A. If area is increased, the resistance will decrease. If area is decreased, the resistance also increase. Understood? Third, it depends very important, that is for nature of the material. Which type of conductors we are applying. If they are taken, it is a silver wire we are taken, then the resistance is low. Then the resistance is low. Resistance is low. If they are taken it is in iron metal, that is they are taken, that is for resistance is high. Its resistance has become high. If they both combine, that is directly proportional and inversely proportional, we are combined together. If we combine together, R is proportional to L and R is proportional to 1 by A, area of cross sectional, then R is equal to resistance, R is equal to, that is for rho, that symbol is rho, RHO, rho into 1L by A, that is for L ones are L and A should be denominator, you see here. R is equal to L into 1 by A, right? What we will get? L 1 by L divided by A. This is the final answer, that is the symbol is rho. Understood my point? First is it directly proportional to the length of conductor. If length is increased and resistance also increase. If length is decreased, then the resistance also decrease. And in the inverse proportional, that is cross sectional in the fraction form will get area will increase, then resistance will decrease. Here, in the area decrease, then resistance also increase. Nature of the material we are taken that it is for in a silver, then the resistance is low. If we are taken in iron metal, that is for metallic iron, that is for resistance is high. If combined together, R is equal to rho into L by A. Got it? Now I am going to explain resistivity. It is a fundamental of material, basic material that resists the flow of electric current. Fundamental means basic of material, basic material that has resist to flow of electric current. That is rho is equal to the general mathematical form we are done. That is rho is equal to R into cross sectional area, resistance into cross sectional area divided by length of a conductor. It depends on the length of a conductor. Only we are studying the factors depending on the material, right? Nature of the material. Resistance into area of cross section, that is into length divided by length. And SI unit that is for resistivity is ohm meter. Ohm into meter, that is for resistivity SI unit. So it is a constant. It has a constant to maintain the balance of flow of current. And the SI unit is range in silver of resistivity, that is for 1.6 into 10 to the power of -8 meter. That is for general value. And mathematically that is solved. Then range of resistivity of metals and alloy is, what is the range? Then the metals and alloy, that is alloy is also one of the metal we are using. So 10 to the power of -8 to 10 to the power of -6, that is ohm meter. Understood? Ohm meter. Range of resistivity of non-metals. Non-metals means that is for insulator. Non-metals, that is for non-metals means which does not carry current, just as a wood, plastic, these are all non-metals. That the value is 10 to the power of 2 to 10 to the power of 17 ohm meter. That is for insulator, that is for non-metals. Similarly, the third point, copper and aluminum used for electrical transmission, right? That is for electrical transmission. Copper wires and aluminum, you saw on the roads and all, they have copper wires, aluminum wires. In home, we are using, that is for copper wires. So the transmission of electric current, and they have low resistivity. They have low resistivity. Alloy is used in electrical heating device. Alloy is using as a electrical device or heating device, that is for heater, geyser, these and all. They have resistivity. As their resistivity is high, they do not burn and they do not as soon melt. They do not burn readily. As soon it will not burn or it will not get melt also. Understood? These are the points will be the resistivity we are used. We are done on that. So there is for copper and aluminum is has a low resistivity, and alloy is also electrical heating device, that is for we are using in a example, that is for heater and all. Understood? Okay. And one more thing I will explain. What do you mean by resistor? Directly I will get the definition. A resistor is a electrical component. It is a electrical device. Electrical device or component that limit or regulate to the electric current. It is used, for example, we are using a fans, lights and TV. This and all we are using, that is for it was connected to the resistors. It is connected into the device. That device is connected into the fans also and TV also, and so many home appliances we are applying in a home. That is, it is connected as a resistor. Understood? Okay. Next I am going to explain resistance in series. You know the resistance of series. How to conduct this is resistance R1, R2, R3. This is in series. Parallel means back to down, up and down, up and down. It will come down to down, down to down. Like that. Which is connected ammeter, battery. This is plug in. And resistance 1, resistance 2, resistance 3. Voltmeter also connected here. First junction on the resistance R1. We will check the flow of current. And first point. What is the first point? First point. The flow of current in which direction? The flow of current in which direction? That is from positive to negative direction. Positive to, from starting from positive to. From positive to it was start. The flow of current from positive to negative. From positive to negative. And in a circuit, the flow of current is equal. The flow of current, what it will be? The voltage, it will becomes equally, it will inflow. Understood? And the second point over. And the third point, voltage of R1, R2 and R3 are different. The voltage of current is different. That is V1 is equal to IR1. That is first resistance. And similarly, V2 is equal to IR2, second resistance. And V3 is equal to IR3. These are the three resistances of the given voltage of that. That is, if we need to check first voltage R1, if we need to check the resistance of that, the flow of current, the voltage is how much degree it is going, easily we have to keep one voltage, that is for voltmeter, and connect it to the resistance, we can get easily to the, what is the voltage is supplying here onto the resistance 1. Understood? So after that, so voltage, that is for V, capital V is equal to, we know that V1 plus V2 plus sum of 3, that is right. And so volt is equal to V1. V1 is what? IR1. V1 is equal to IR1. And what is the general formula? V is equal to I into R. That is V is equal to, that is for potential difference is equal to I current into resistance, right? Plus V2 is IR2 plus V3 is IR3. There is the resistance. V is what? Opposite of the V is I into R. I into R is equal to I. And what is the common in that? I get taken. That is resistance R1 plus R2 plus R. And the both side I get cancelled. And the resistance I is equal to sum of 3 R1 plus R2 plus R3. These are the three resistance we are getting into that. Sum of three resistance in that is in series. R1 R is equal to, that we got in the sum of three resistance, that is for R1 plus R2 plus R3. This is in series. Next class I will explain in resistance in parallel. Thank you for watching.